Okay, this is section 3.8, formulas for linear arithmetic sequences. This is the word. Okay, when you were in kindergarten, oh, my slate's not picking up here. There it is. When you were in kindergarten, you call this arithmetic. When we are talking about sequences, we pronounce it arithmetic. Makes you sound smarter, and it helps us to know that we're talking about these types of sequences. So arithmetic. Okay, we're going to discuss explicit and recursive formulas for linear sequences, and we are going to evaluate them. We're going to go back and forth between recursive and explicit today, and we are going to come up with a formula for these explicit formulas. And it is very helpful because if you're looking for terms way down the road, explicit is much nicer than recursive. It's very helpful. Okay, words to know. Constant difference. When we go here to our sequence 2, 4, 6, 8, dot, dot, dot. Constant difference is, I'll make this a little smaller, there you go, is what are you adding each time? I'm adding 2, I'm adding 2. Okay, so we call it D for difference, and it would be 2 in this case. That's what we're adding. It could be a negative value if I had 100, 98, 96, 94, dot, dot. What am I doing each time? Subtracting 2, subtracting 2, subtracting 2. So in this case, D would be negative 2. Okay, so the constant difference is what we're doing to the sequence each time. This only happens if we are adding or subtracting. And that's the only type of sequences we're dealing with today. And they are called linear, which I never call them linear. I always call them arithmetic sequences. Arithmetic sequences are sequences that you get from adding or subtracting. The other types of sequences are called geometric. We'll talk about them later, and that comes from multiplying or dividing. But we are going to do arithmetic today, and it comes from adding or subtracting, which should be easy to remember because what is the first type of arithmetic you use? When you're in kindergarten, they teach you to add. Arithmetic, you're going to add or subtract. Both of those sequences I showed you a second ago were arithmetic sequences. Okay, 2 formulas to change your life forever, for the better. You'll like it. Okay, this one we've already talked about. A sub 1 equals whatever it is. Let's call it, we can say 1 if you want to. Okay, this one is old. A sub n is the one before it, plus D. The rule always had that number that you added or subtracted each time. So notice that D shows up here in this formula. This is old school. This is what we did a couple days ago. The explicit formula. This is the formula that will help you write the explicit rule, which is much more helpful when finding those later terms. You will have to memorize this, okay? This is one you're going to have to memorize. And here it is. A sub n is a sub 1 plus n minus 1 times D. Now, I do have it memorized that way. But whenever it's written this way, sometimes you guys have a hard time remembering to distribute. This D has to be distributed. So even though it's written behind, it has to be distributed. The reason a lot of texts don't write it this way is because that might give you the impression that D always has to be positive. D can be negative, and if it is negative, it's going to affect both this n and this minus 1 because you're going to have to distribute it. Okay, so let's go back to the 2, 4, 6 one. If I wrote it as a recursive, we know this. A sub 1 equals 2. A sub n is a sub n minus 1, the one before it. What am I doing each time? Adding 2. And then we say 4 integers n greater than or equal to 2. That's recursive. Explicitly, it would be a sub n equals, what is a sub 1? 2 plus n minus 1 times D. What was D in this case? What am I adding each time? 2. Distribute. 2 plus 2n minus 2. Those cancel. A sub n equals 2n. If we were subtracting each time, and you would have negative 2 here, make sure you put that in parentheses because then it would distribute still. It's not subtraction then. Okay? I could actually show you an example just in case. 100, 98, 96, 94, dot, dot, dot. A sub n equals, what is the first term? 100 plus n minus 1. What is d here? Well, what am I doing each time? I'm subtracting 2. Put it in parentheses. Distribute. I'm going to go down here now. A sub n equals 100 minus 2n plus 2. 100 plus 2, 98 minus 2n. Okay, this always comes up, and I'm going to go ahead and address it now. What is it, this n minus 1? Why does that show up in the formula? I'm going to tell you why. I could graph this as an equation of a line. Y equals 98 minus 2x. Okay, if that was the case, oh, this is not even right. Why didn't anybody tell me this? Oh, because no one's here. That's 102. Excuse me. Okay, 102 minus 2x. If I graph that, the y-intercept's up here at 102. And each time I'm going down 2 over 1. So my slope is negative 2. This is a constant decrease situation. And this makes sense because my sequence is decreasing. I shouldn't connect the line here because this is discrete. I can only plug in ones, integers. But the reason the n minus 1 is there is because it was the initial condition would be 102 because that's when it would be the 0th term. Well, there's no such thing as a 0th term. So we start at 1. So basically what they're telling you, 1 is where that 100 shows up. The n minus 1 is saying if you wanted the y-intercept, you'd have to go backwards one spot. You don't need to know this, but some kids are confused. Why can't I write it as a initial condition problem? Well, because you're not going to get it right, because that would put your, instead of a first term, you'd have a 0 term, and that's not what we're dealing with. So this formula does need to be memorized. Okay, this is what I was talking to you about in class, the sequence command on your calculator. It is an option, but I'm going to tell you if you want to generate a sequence on your calculator, what I suggest you do is get that explicit formula. 1, get explicit formula. 2, plug it into y equal, or f of x equal if you're on the Inspire. And then 3, generate a table. If you generate a table, then you're going to be able to see the terms. Just make sure you change your delta, what does it say? I don't remember. Delta x, you're changing x, your step, so that it's 1. Start your table start at 1 also. And then you'll be looking at the first term, second term, third term, whatever. There is a command, but I think it will just cloud your brain, like I said. And if you're interested in it, I will talk to you about it, I guess, next time I have you in class. Oh, I didn't want that to happen. Okay, examples. Consider the arithmetic sequence 12, 16, 20, 24, 28. Write an explicit formula for the nth term of the sequence. Okay, a sub n equals a sub 1 plus n minus 1 times d. A sub 1, that's easy, that's 12, plus n minus 1 d. What am I doing each time? Looks like I'm adding 4. So d is a positive 4, so I'll put it in here. Go ahead and distribute. (12 minus 4 is 8. 8 plus 4n, that's my explicit formula. You could change the order around if it makes you feel better. Recursively, what would it look like? What is the first term? 12. What is the recursive rule? What am I doing each time? I'm taking the term before it. I'm adding 4. When am I doing this? For integers n, not 1, I'm going to start with 2. Calculate the 47th term. Well, which rule am I going to want to use? Explicit or recursive? Hopefully you're all saying go with explicit. I'm looking for the 47th term. This is very convenient. I just plug it in. 8 plus 4 times 47. 4 times 47. Oh, calculator, don't let me down. Plus 8. Looks like 196. Tell me if you get something different when you come back to class. Okay, moving right along. Sometimes we have to figure out what the first term is. Sometimes they don't give you the first term. So what do we do? Let's look at problem 13 in the book. This is a bad copy. So here's what they give you. I need to actually go to annotate over. Okay. At the right is a graph of the first 5 terms of an arithmetic sequence. Write an explicit formula for the sequence. Well, points I have given are the third and the fifth. So I got 3, 5, and 5, -3. I need to figure out what that slope is. What is this change in step? Because these are in between dots, I can't quite tell what the first term is. Okay, so I have -3 minus 5 all over 5 minus 3. -8 over 2, which is -4. Okay, so every time here I'm going down 4 over 1. We could go ahead and find the equation of the line, but I don't think that's necessary. So the second one, each time the change is 4, so I'm going down 4 each time. Oh, because this is 15. I was going to say, it just doesn't look like it's adding up right. So if I go up 4, that would be 9. So 2, 9 looks like it's the next one. Up 4 more, because we're going backwards here. This will be 1, 13. First term is 13. Okay, so now I can write the first 5 terms of, here's an explicit formula. A sub n equals a sub 1 plus n minus 1 times d. I'll go right up here. A sub n equals a sub 1, what did I just say? 13 plus n minus 1 times d. Each time we said the slope was the same as that rate of change. I'm subtracting 4 each time. So -4. Make sure you distribute that properly. 13 minus 4n plus 4. A sub n is 9 minus 4n. That's my explicit formula. Kids are going to walk in here in 1 second. I'm trying if I can hurry up and get this done. Number 16, a weekly contest gives away a cash prize on a local radio station. Let me pause this. Okay, sorry. The announcer calls someone, and if the person who answers gets it correct, they win this money. If not, the $25 is added to the pot. So they're saying the pot starts at $140. So a sub 1 is $140. Then each time, if it goes on, they're going to add $25. So a sub 2 would be $165. A sub 3 would be $190. Okay? So on what call will we get to 1,115? I don't want to do this all day. That really kind of stinks. So we're going to write the formula. A sub n equals a sub 1 plus n minus 1 times d. First term we were given is 140. N minus 1. D, what am I doing each time? I'm adding 25. Go ahead and distribute. A sub n equals 140 plus 25n minus 25. I'm sure these locker sounds are driving you guys nuts. I have 115 plus 25n. That's my explicit formula. Now, they're not asking me for my explicit formula. So why did I do it? Well, I know I'm trying to figure out, that's not right. 115 plus 25n. I know I'm trying to figure out what call. So that's really, this number is what I'm looking for. Okay? This is the total. This is the actual term value. So a sub n equals 1,115. I'm looking for n. So I'm going to plug in 1,115. Why do I keep putting so many ones? I'm solving for n to figure out what term number that was. Subtract 115 from both sides. 1,000 is 25n. Divide out, and then we find out it's going to be the 40th call. You really need to understand the explicit formula on that, because you have to realize this is a sub n, and we are trying to figure out what n value that works for. Okay, on tonight's homework, which that will be Tuesday, you're going to skip 22A, and that was just a lanyard check. And that's all I got. Okay, see ya.